Okay, so we're given this graph, and you've got numbers, you've got a scale, you got -2, -1, 1, 2, and you recognize this graph as the graph of 1 over x squared. Because it's a basic function. And this type of problem will always give you one of the basic functions. Okay, so then we have the points here. 1/2, 4, and the scale on my picture is not that good. This isn't 4 times as high as this, right? And it should be. And I'd expect you'd be able to figure out points. If I gave you just any graph, you could, by the scale, estimate coordinates of points, right? Now, how do you do the inverse? You switch the x's and the y's, right? Now, you could write out the table, like we did here, and switch the x's and the y's, and then graph those points, right? Okay? Because of time and because often you'll be able to just kind of skip that step. What happened to my green chalk? Who's got my green chalk?
Elena.
Yeah, well, I figured it was her, but I wanted somebody to rat on her. Okay. I used green chalk before. I'd like to use green chalk again. Green chalk gone. Well, I'll use a different color. Yeah. Oh, good job. Good job.
Justin.
Okay. Next time I'm in a quandary between 2 scores, I'll give you the higher one for that. Okay. If I'm not sure which one, I'll go in your favor. One time only. Okay. Otherwise, it's a coin flip. Now, okay. Okay, so I can plot all these. I can plot all these points, switching the x's and the y's, can't I? So let's say -2 1/4 would become 1/4 -2. So let's go ahead and get our -2 and -1 here. So let's see, 1/4 would be here. 1/4 -2 would be here. Negative 1 would become 1 -1. -1/2 4 would be 4 -1/2, so we have to get 4 out here, right? And then -1/2 would be here, so we'd have a point here, and now we can do this, right? And then 1/2 4 would become 4 1/2. Okay? 1 1 would become, well, switch those and what have you, you get 1 1, so it's going to be the same point. And 2 1/4 will be 1/4 2. So maybe that's here. Okay? Understand what I just did?
Yes.
I just switched the coordinates, tried to be careful so I wouldn't screw up, but probably did one time or another. And now I can sketch a curve that goes through here, and that makes sense. Okay? Now, if I want to graph the inverse function, okay, what do I have to do? This is a relation, not a function. Okay?
Same thing, inverse relation.
That's an inverse relation. If I want an inverse function, I've got to choose either this branch or this branch. Okay? And down here I could have chosen either branch, but this is the only one that makes sense for a square root, so that's the one I chose, right? Okay? I could actually choose either branch because I'm not trying to match it up with a specific function, right? Okay? So I'm going to go ahead and choose this branch just because I like positive results. Okay? But I could have chosen this branch. Okay? And this branch, I'll just tell you, would have been one over square root of x. This branch would have been negative 1 over square root of x. It's kind of neat to see that, but you don't have to know what it means just yet. But when we get to dealing with the algebra of inverse functions, okay, you're going to see why that's important and relevant. And you'll have this picture to use to understand the algebra, okay? So you won't have to start from ground zero, okay? Now, how many of you seen inverse functions before this course? Okay, everybody should have, but yeah, I know. Okay, about half of you.
I've seen it years ago. Like
Yeah, years ago.
2004.
Okay? So, I know it's rusty because it always is. Not necessarily for everybody. I always have people that come in pretty much knowing it, at least enough to start. Okay? Some people know it quite well, but usually not. So, that's why we do this.